Last week, on my newsletter, Import React, we sent out this article by TK Dodo, who, if you don't know, TK Dodo is actually one of the main maintainers of React Query, and his articles are really of high quality. And this one is called the useless useCallback. This article essentially demonstrates how in real-world scenarios, more often than not, this whole concept of memoization is actually useless. Using useMemo and useCallback actually achieves nothing, and you're better off even without it. And what's interesting about this is that this is not even because the developers might be using these memoization tools wrong, right? Because as we know, using useMemo and useCallback, it's very easy to not do the right thing, to not use them correctly, which many junior developers tend to fall into, and then introduce performance problems into your application. This article is not about that. This article shows that even if you have good, experienced developers who do use useMemo and useCallback correctly, more often than not, in a real application, it falls short and the whole memoization breaks. It essentially illustrates just how fragile this whole concept of memoization even is, and it's like a stack of cards, right? If one piece is missing and if one piece goes down, the entire stack of cards goes down. So in this video, I want to cover this topic. I've gone ahead and created my own application with my own simple examples so that we can actually see what's going on and realize that in most cases, we're actually better off not even using memoization at all. And make sure to stick around until the end of the video because I'm going to share with you a very interesting pattern in React using refs that you can actually use to solve a very specific problem in the context of useMemo and useCallback. And I'm pretty sure that you haven't heard about this pattern before. So get ready. This is going to be a very interesting video. But first, before we get into that, let's take a quick moment to just talk about the sponsor of today's video, Brilliant. Brilliant is a learning platform that helps you become a better thinker and problem solver. They have thousands of visual interactive lessons covering a wide range of topics like math, science, programming, data analysis, and AI. Their learning platform is actually designed to be uniquely effective. Each lesson that you have on Brilliant is filled with actual hands-on problem solving that lets you play and interact with the concept that you're learning. This is a method that, by the way, has been proven to be 6 times more effective than watching a traditional lecture video. The courses on Brilliant are designed to build your understanding from the ground up, and they actually mix engaging challenges with competitive features and daily reminders to help you stay consistent. Plus, all of the content on Brilliant is crafted by an award-winning team of teachers, researchers, and professionals from big known places like Stanford, MIT, Microsoft, Google, and so much more. And if you're into programming, which of course you have to be if you're watching this video, they have a growing collection of programming courses that are a great way to build timeless problem-solving skills to thrive in this ever-evolving world of programming. From learning Python to developing an intuition for computer logic, you're going to get hands-on experience with real programs, and you're going to learn to think like a programmer. To try everything that Brilliant has to offer for free today, you can go to brilliant.org/costandsolutions, or you can scan the QR code on the screen or use the first link in the description. And for my viewers, Brilliant is actually offering 20% off an annual premium subscription, which gives you unlimited daily access to everything that Brilliant has to offer. Thank you once again to Brilliant for sponsoring this video. And now let's get into talking about the uselessness of memoization in React. All right, let's begin. Now, this is the article here. Once again, I have to give credit to this because this is the inspiration for this video. You'll find a link to it in the description down below. But if you're subscribed to Import React, which is completely free, by the way, you would have seen this last week alongside other very high quality links. We're not interested in this article for this video. We are interested in looking at actual code. So here I have a couple of components. I have the grandchild, the child, and the parent. We have ourselves a nice little family here. We're going to go through each component one at a time and try to spot the problem with memoization in React when it comes to using memo and using callbacks. So let's start with the grandchild and let's see what this component does. So this component here receives some props. It receives 2 props. The first one is items. This is going to be an array of strings. Fair enough. It also receives an onClick function, which takes no arguments and returns nothing. Perfect. Then inside of the body of the function, we have a useEffect over here, which is essentially adding a key down event listener, and it's going to run this function whenever any key is pressed. We're not really concerned about what key or any sort of validation. This is really to just keep things simple for this example. The important part is that the onKeyDown function here is calling the onClick function. Maybe it doesn't really make sense because onKeyDown you're calling onClick. Just ignore that, right? Again, it's a simple example. OnKeyDown, we're calling some function that is coming from the parent, which in this case happens to be called onClick. Now, because all of this is is happening inside a useEffect over here, of course, we have to provide the onClick in the dependency array of useEffect. Then over here, if we scroll down, we actually have this memoized expensive component. So now things are getting a little bit more interesting. This one is receiving the items as props over here. And this one, we can just assume that it's doing something expensive. Maybe with the items, maybe not with the items. I mean, probably with the items because we're passing them through props. But again, I don't have any actual code here. Just imagine that it's doing something computationally expensive that would take a few hundred milliseconds to actually render, right? So this is this component over here. Now, because it's doing that, of course, we're going to memoize it manually by using memo here. We're going to pass it here, and this is going to make it not re-render unless its props has changed, which in this case, unless items here has changed, this memoized expensive component is not going to re-render, which is ultimately what we want, because this expensive computation does indeed depend on the items. And then we have this button here, which just receives the onClick function as a prop over here, and it ends there, right? This button here is a simple HTML element. It's not a component, so there's nothing really for us to really worry about with this onClick function. Good. So now with this, we've seen everything that the grandchild component actually does. Now there's a couple of things here that we want to make sure, right? So first of all, the items here and the onClick function, these better be memoized, right? Because first of all, we're passing this onClick here to this useEffect, right? Which we kind of want this to be memoized. Otherwise, this is going to run on every single render, and we're going to continuously create an event listener and then destroy the event listener, which is not ideal. It's not the worst thing, but it's not ideal. And then we have these items over here, which we also want to have them memoized. And this is way more important because we're passing them as the prop to this expensive component. And if they are not memoized, then this expensive component is going to re-render over and over again, which is not what we want. Now, there's one important thing, which is a huge misconception that a lot of junior developers end up thinking that you have to do. We are not concerned with this button over here, the fact that it receives this onClick. In this case, we do not care if this onClick is memoized or not, because we're passing it to a button here. This is not a component, right? This is not a component that can re-render, that has a life cycle or anything. This is a pure HTML element that does not care about the memoization of its props. So in this case, we don't care. We don't need to memoize onClick. And if it was just this button component here, we would have no problems, right? The only reason we're worried about this onClick here is because it is being passed to this useEffect as a dependency array. That's it. That's really important to know because you don't need to memoize everything, and not everything that is passed as a prop to any HTML element or component always needs to be memoized. Cool. So now let's move up in the family tree and let's go to the child and let's see what the child is doing. So here we have the child component. This one also receives props. This one receives again the items as a prop. This is the same items over here that it's passing to these items here. However, it's doing something to these items, right? We're essentially taking all of these items here from props, and then inside of a useMemo here, we are actually mapping over each individual item, and we're processing that item by, say, just turning it to uppercase here. And then we have a handleClick function, which is using useCallback over here. And then it's just logging the processed items, and it's using the processed items as a dependency array, right? So it's using the items that have been memoized over here as well. So far so good. Both of these props are then being passed to this grandchild as items, the processed items, and then on click, we're passing the handleClick function. Now, so far so good, right? Everything up until this point looks completely legit. Here, we have two use cases of useMemo and useCallback that are completely valid, right? In this case, it's very justified to be using useMemo and useCallback because you're receiving an array here from the props and you're doing something for each element in the array. Well, of course, you want to memoize that so that you only perform that operation every single time that the array changes. You don't want to be processing every single item, every single render of this child component, because again, this child component may re-render for some other unrelated reasons. You can never know. In this simple example, it won't, but usually in a real scenario, it would. So you don't want to be running unnecessarily this processing here if the items didn't change. That's why we memoize, right? We have items, we have some dependencies. We only want to run the code for each item every single time that the items array actually changes. So this useMemo here is a valid use case of useMemo. Now, moving on to this use callback over here, this is also a valid use case of memoization. Now, in the case of use callback, we're not really concerned about the contents of the function. In this case, nothing's really expensive here. We're just doing a simple console log, but we are concerned about the fact that we're passing it on click to another component, and this component is going to use it inside of a use effect over here, right? So because of that, we want to prevent this re-render, and so we're using a use callback so that we can always pass a stable reference to this function. Unless, of course, the items changes over here, the process items, which is, of course, what we want because this function actually depends on those process items within it. All right, so far, it's looking good. All of our components are following best practices, right? Everything is memoized. We're using valid use cases of useMemo and useCallback, so we shouldn't really be having any problems. Well, let's now go and look at the parent, who I suspect might be the source of all the problems. So our parent component is actually the simplest component, right? Because it's at the top, it kind of gets to decide everything that happens within this family, right? The only thing that it's doing is it's creating the actual items array that is getting passed to every single component, and it's passing it to the items property over here of the child component. However, if you notice here, the way it's creating this items array here is it's just defining it in line of the component. This items array is not memoized, which means that on every single render, it is going to have a different identity. It is going to fail a reference equality check, which of course means that everything is destroyed, right? All of our memoization in all of our components is actually rendered useless because of this one line of code here, right? This component, although simple, just by one line of code, it completely invalidated all of our memoization across our components. Right? Because here the items receives this non-stable items array, which means that every single render, this items here is going to be different. So this useMemo is going to get recreated because again, it's a new items array. So processed items is going to be different, which is then going to invalidate this use callback over here because it's listening on processed items, which if we come here to this grandchild component is going to invalidate both of these props over here. The use effect is going to be triggered, and even worse, actually the worst of all, this memoized expensive component is going to be rendered, even though in every single step other than the parent, we've actually done the job to memoize things super correctly. And this is the problem. This is unfortunate, and this really illustrates how fragile memoization is in React. Because if you make one mistake, you forget one thing, everything completely breaks. Now, you might be thinking to yourself, well, this is easy. We can just memoize this items array here, or even better, just put it outside of the component because it doesn't seem to depend on anything, and that would solve all of our problems. And you're right, it would. But that's not the point of this video, and that's not the point of the article that is trying to make. This may work in this simple application over here with 3 components, right? All written by me, the same developer. I can easily spot this and just fix this and then call it a day. But in the real world, this is not that easy. It's not that simple to actually find the problem here and fix it directly. Oftentimes, in a real application with many components and even many developers working on those components, this child here is not only going to be rendered by one single component, like the parent. Maybe there's some uncle, right? Some distant uncle that just wants to break everything, and it's also using the child component here, and it's passing a non-memoized version of these items over here, right? Because the way that we have it here, every single place that we do use this child component here, we need to make sure that we pass a memoized version of the items to it as its props. Because if you're here, if you're working in this grandchild component and you have this performance problem, you now have to go and look through every single component in your application that's using any of these components here, right? Because any of these components could have a problem, and you have to find and make sure that everything is memoized. And again, in a real application, your components aren't going to be simple. You're going to have many use memos, many use callbacks, many use effects, many chains of dependencies, and you have to find the one plug, the one mistake somewhere in that. It's like finding a needle in a haystack. And this is so difficult to do, and frankly, in a real application, I would even dare to say that it's impossible. You can't obsess over this and try to make sure that you plug every single hole. It's not worth it, right? It's an uphill battle, as the article says, right? It's not worth fighting this battle to really obsess about memoization. And look, the truth is that in most cases, this is actually not even a real problem that you have to worry about. In React, re-renders are not really a problem. You can have things re-rendering all the time. It's usually fine, right? Re-renders are good because it means that you're showing the up-to-date value of the things that you're rendering. What is a problem is expensive renders, slow renders, right? But even those can be avoided with some really smart design of your components. Because if we look here in this child component, right, it's not really a problem if we invalidate all of these things here. Maybe it is a problem that we're running this items.map here over and over again, even if the items contents didn't change of the array. But if we have like 5 items, this is not an issue that it's worth worrying about. Certainly not to now go over all of your application and obsess about every single use case or missed use case of useMemo and useCallback. This handle click function, again, we don't really care that it's not memoized every single render, right? It's being passed to another component and we're fine. We don't care beyond this. Again, this is from the perspective of the child. The grandchild over here, yes, it is going to run this use effect unnecessarily every single render, even if the onClick or the things inside of it didn't change. But again, we're adding an event listener and we're removing it. It's not really that big of a deal. The user is not going to see this, right? So is it really worth it to now go and obsess over every single use case of useMemo and useCallback? Not really. Now, we do have this memoized expensive component, and here, yes, this is a real problem because this is an expensive component, so it is going to take time to re-render, and ideally, we want to only do this if the items actually changes, right? So this is a real problem, but that's kind of the only problem that we have in our application. So instead of going over all of the application and trying to fix everything, maybe we can just fix this problem directly here and be done with it. Because when you think about real applications, sometimes you won't even have access to the parent component over here. Maybe this parent component is on some other feature that is owned by a totally different team, right? So you can't really have access to it. You can't make changes to it. You're only supposed to work on this grandchild component, and this is your problem over here. Yes, you might make a request to the team to go and fix it, but you never know when they're going to get to it, if they deem it as important or not. That's just the reality of working within a real project with many developers. So you have to find a solution directly locally here to solve it. And I have a few solutions for you that you're going to find really interesting. So first, before we fix this memoized expensive component here, let's just quickly fix this use effect here, because I want to show you a really cool pattern that I mentioned in the introduction of the video. So this is the really cool pattern. You can actually get rid of having to provide this onClick here in the dependency array by using a ref instead with another use effect. This is interesting. So our problem here, right, is because this onClick function is used within the use effect, we have to provide it in the dependency array, which means that our use effect is going to rerun whenever this changes. Now, because we've established that this is going to change every single render because of our missed memoization here, this is going to run unnecessarily, but we can avoid that. What we can do instead is we can come in here and we can create a ref. We can do here onClick ref, and we can use a ref here, import it from React, and then pass it here the onClick function. This is now going to put our function inside of a ref. And then what we can do is we can come here and put a use effect. We're going to use another use effect. And here, we're not going to pass any dependency array whatsoever at all. You can do this in React. If you don't pass any dependency array whatsoever, this use effect is going to run on every single render, regardless of what else happens. And what this effect does is every single render, it assigns the new value of the onClick to the ref itself, right? So we're always going to get on this ref here, the new value of the onClick on every single render, which is really cool. This is called the latest ref pattern because in every single render, we're assigning the latest value of the thing to our ref. And then we can come inside of our use effect. And now instead of calling the onClick, we can call the onClick ref.current, right? Call the function, and then remove it from the dependency array. This is going to do the same exact thing, but now this use effect is only ever going to run once because we're using a ref. You don't pass refs to dependency arrays because they are not reactive. And this is a really cool pattern. Shout out for TK Doyle for mentioning it in his article, but I believe this is by Kent C. Dots who created this pattern. So shout out to them because it is a really, really cool pattern. This essentially allows you to have imperative access to your function and bypass the React render cycle and not have to provide something in the use effect dependency array when you don't need to. And this is a valid use case, and this is a valid approach for it. This is actually what React Query uses internally for some of the things. I believe when you pass the options to a query, they use this pattern over here because they need to provide it to some dependency array, but they don't want it to be reactive and cause the whole dependency to re-render. So this is a great pattern that you can use, and this solves this use effect problem. So now, how do we fix this memoized expensive component here? Because as we've said, this is the real problem here. Now, there's two solutions that I can provide you. The first one is the naive solution. This one is to come here to our memo here, and as the second argument, we can actually provide a function here, an equality function, that is going to allow us to run any code that we want to compare the previous props to the next props, and we determine ourselves if we want this component to re-render or not. So in this case, we can do something like maybe check the length over here. So length like this, right? We can check that the length matches, right? If you do want that. So let's put the length over here. That's a check that we can do. I wouldn't recommend that you do just this check because again, your array might change. One element might be removed, one element might be added, and they would still have the same length and your component wouldn't rerun them. So you don't want that. Usually you want to also make a check and then check that every single item in the array actually matches and is exactly the same item, right? That way you can guarantee that every single element in your array has or hasn't changed. Now, if you're looking at this code, you're going to realize that this is not the best or most ideal solution because every single render, we're having to map over every single one of these items over here to determine if we shouldn't re-render. And in some cases, you might be surprised running this code is actually more expensive than the render itself, even if the render is expensive. So you really have to kind of play it by ear, right? By use case and figure out, is this something that you want to do? Or do you just want to let the render happen and because this isn't worth it? Something that you can also do, you can do like the JSON stringify version of these items over here, right? Again, that is also expensive. I mean, relatively, that is also going to run some code on every single render, and you have to decide if this is worth it for you or not. Now, the second way that you can do it here, it's going to be a little bit difficult to kind of illustrate because this is, right, there's nothing going on in this component, but generally, if you're smart about how you design and architect your components, you can actually get rid of many of these expensive things just by doing things right. If instead of having this one big expensive component that is doing something and then rendering a bunch of things, maybe you can split this into smaller subcomponents, you can split this maybe into different hooks, and you can kind of isolate that expensive computation in a way that maybe doesn't prevent the rendering. Or maybe you show some loading spinner or something while this is happening if it's really expensive, right? But there are ways to architect your components to not really have to run into these issues at all. And the reality is that these issues here with memoization and stuff like that, you don't really run into all that much in terms of performance problems if you're architecting your components correctly. I don't really have performance problems in my applications, and I haven't really had them for years because I learned that if you build small components that follow the single responsibility principle, right, they only do one thing, you don't really have expensive problems, expensive renderings. This usually happens when you have big components that are usually trying to do too much. So just by looking at your components and breaking them up, you might fix this problem and you might realize that this is not even an issue in the first place, and this is just a problem of component architecture. And if that's the case, well then, all of this no longer becomes a problem. You can have items re-render as much as you want, right? You don't care because everything is super efficient, everything is super lean. And that's how a React application actually should be, right? Again, re-renders are not bad, they are good. It means that you're showing the updated values of the things that you're using. Now, of course, this is not to say that if you have a simple case like this, an isolated case like this, and you see that you forgot to memoize this, or even someone else from your team of developers forgot to memoize this, yes, just go ahead and memoize this component here, right? I'm not saying to just never memoize and to just drop it, right? It's fine if you memoize. But again, the point is, don't obsess over this memoization and don't obsess over making sure that everything is perfect, right? But if this is the simplest solution for your one isolated problem over here, then by all means, go and do it. It's not that big a deal. And finally, now that we have the React compiler, which still isn't beta, but whenever it comes out of beta, you should be using it in your React applications because the compiler is actually going to catch this automatically and it is going to fix it. And it is going to fix it in any other place that you're using this child component here, right? So now it no longer becomes a problem that you have to manage, which means that you also don't need to manage by memoizing all of these things, right? It just does it across the board. And for the most part, you are good to go. Now, I say for the most part because even with the React compiler, it's not perfect and it's not always going to solve all of your problems. I actually just made a video on this recently. The React compiler is good. It does a lot of the memoization for you, but there are things outside of the memoization that you also have to be careful about. So even the React compiler is not your end-all be-all solution. You really have to understand memoization in React, understand component architecture to make sure that you don't run into any of these problems. So yeah. Now with this, we've seen, I think, the most problematic React family tree, right? This is a very chaotic family. And we've seen how just one bad decision from the parent can ruin the entire family for literally generations, right? So I hope that you were able to understand kind of how useless useMemo and useCallback is and how there are different ways and different approaches that you can take instead. And once again, shout out to TK Dodo for this super great article. I learned a lot. I highly encourage you to read this because it's really insightful and you can see his own real use case working at Sentry. history, which was very interesting. And you should definitely, if you haven't already, subscribe to Import React, because you're going to get articles just like this delivered to your inbox every single week. So that's it. That's all that I have for this video. If you've enjoyed it, make sure to leave it a big thumbs up. You can also click here to subscribe, or you can click here to watch a different video of mine. My name has been Darius Causin. This is Causin Solutions. Thank you so much for watching, and I will see you in the next one. Ciao, ciao.